So an empirical formula, that was one of the conversations we had, and it was specifically to something like sodium chloride. I said, what if I wrote this? Would that be the correct formula? And everybody correctly identified that no, it would not, because it wasn't in its simplest form. So there's a danger there, because NaCl is truly the chemical or molecular formula for sodium chloride, but this guy is hydrogen peroxide. That is its molecular formula. The simplest form would be this. So what do we do about that? This would be considered the empirical formula. It is the simplest way that these two things can go together. But so long as these relationships stay the same, this is hydroxide, this is hydrogen peroxide. So they're actually two different things. They do different things, or behave different chemically. But this does have value to us, and we can, actually in one of your labs, you will determine, I'm sorry, I was trying to remember if it was this quarter or next quarter, an empirical formula from your evidence, or from your experimental results. So let's talk about how to do that. This question says that we have 83.5 grams for a total sample, and it contains 33.4 grams of sulfur, and the rest is oxygen. So the first thing we need is to know, so sulfur has 33.4 grams. So in this approach, we need the mass of the oxygen. So if the total mass is 83.5, if we subtract the 33.4 that sulfur is taking up, conservation of mass says that 50.1 grams, whoops, is the mass of oxygen. Now we need to know what the actual mole mass is for both sulfur and oxygen. Now I've said oxygen enough tonight. So its atomic mass is 15.39123 grams. And sulfur, I gotta look at my periodic table. So we have our grams per mole for, did I do that right? Yeah, I did. Okay, sorry. Grams per mole for oxygen and grams per mole of sulfur. We have, I knew I did something wrong. I went crazy with my per moles. We have 50.16 grams of oxygen in the sample, and we have 33.4 grams of oxygen in the sample. We need to get things in terms of moles. So if we start off with sulfur, we say sulfur has 33.4 grams, and we want moles on top. So moles sulfur, and I told you I wanted you to have a habit, and I'm already breaking it for you. 32 grams of sulfur times 1 mole of sulfur in 32.066 grams of sulfur. And oxygen, let's do the same thing. Make sure you can see. I have 50.1 grams of oxygen, not O2, just oxygen, times 1 mole of oxygen has 15.999 grams of oxygen. So grams oxygen cancel, grams sulfur cancel. I have mole sulfur and moles oxygen. So let's button push and see what that comes to. Okay, and I check that and I say, okay, so that answer comes out to 1.0416 moles of sulfur and 3.134 moles of oxygen. But for molecular formula to look like, let's pick something normalish looking, NO2. I can't have NO2.134567. It's going to be NO2, period. So what the trick here is then to divide by the smallest mole number that has popped out and see what it's going to be. And as you can see by inspection, it's going to be 3 to 1, but let's just double check. So 1.0416 divided by 1.0416 gives us sulfur has 1 mole, and oxygen 0.1345 divided by 1.0416, and we get, thankfully, 3.006. So indeed it is just 3 moles of oxygen. So now we can put those pieces together, because we're going to stop here, and say that our empirical formula, now keep in mind this might not be the actual molecular formula, but our empirical formula is going to be S1O3. That is the empirical formula.